do the free body diagram, and then E we must do it. It's the equation of equilibrium. So we'll start with point G. We can see here the free body diagram as we did it. So the force FGH and FF, the force FG. So we do the the equation of equilibrium at point G. So we did it, and we get the value, and it's all like tensile forces. So then we continue with point H, and we do the same. We draw the free body diagram, and we go to the equation of equilibrium, and we get it here. As we can see in at joint H, HI, the force is compressive, and the at point FH it's tensile, and we go the same as previous 2 points with point I, and we can see that the force in point and at joint I is compressive, IJ, but for FI it's tensile. So at the same with point F, we draw the free body diagram, and we continue getting the equilibrium of equation, and we get the value, and as we can see it is compressive for FJ, and for the force in EF point is tensile. And we continue with point J, and we do the same process as we done. We draw the free body diagram, and then we continue with the equilibrium of equation, and we get it as here. The force in JK is 97.45, which is tensile force, and with J it's compressive. So here left and right side are the same. So as we can see in the figure above, that PQ and FE equal. PQ here and FE are got the same value. So the answer will be the same. For force in PQ, it's 133.52 kilonewton. So here it's an EF. So we got it here. It's tensile. And also for JK, as here we got it. Then we proceed with point K. We do the free body diagram, and we do get the angle here. So we continue with the equilibrium of equation, and we can see that we will get this. We got this answer. Also at point Q, we do the same, that we draw the free body diagram, and it's all compressive as shown, the forces, except for for force QR it's compressive, but EQ here it's tensile. And lastly, point E, we draw the free body diagram, and we can determine that data is 75. So when we by using a protractor, we can determine that data is 75. So here we go, and we do the same equation, and we get the answers here, the two answers, and we proceed with the point R, and we draw the free body diagram again, and we do the equation of equilibrium, and also force in RS is compressive, as we can see, and all the forces here are compressive, except the force in RS is compressive, but the force in DR is tensile as shown. So for point D, we do the same process. We draw the free body diagram, and by drawing the diagram and using the protractor, we can determine that data is 66. So we do the equation of equilibrium, and we get the answers as shown. And here the members are, we got them here from all the points we did before, and this is all the answer. Hope it's clear.
Greetings to Dr. HAIRUL. My name is NAGESKUMAR SELVAM. My metric number is B09221046. I am a Bmmv student, session 2/1. So I will be doing question 2 in static assignment. So let's look at the question. So the question here is, determine the magnitude of gripping force produced when two 300 Newton forces are applied as shown. So this is basically a cutter. There is two parts, the first part and the second part. So two force is reacting at this cutter. So they ask us to find the gripping force that is acting at this small screw. So let's draw the first free body diagram, which is basically the head. So F is basically the gripping force, the nut. The second one is A. We already given A. The force reacting is perpendicular, and point B over here. So BY, BX, and I already put the length over here. So let's do the summation. So summation Fx is equals to 0. So Fx, there is only Bx over here. So Bx is equals to 0. So let's do the summation for Fy is equals to 0. So the Fy, the force acting direction Y, is Yx plus. So it's moving towards upward. So it's basically positive. So F plus AY plus BY is equals to 0. So let's do the summation for moment. So as a reference, we can take point A. So plus summation moment point A is equals to 0. So BY is upwards, so it's moving to the anti-clockwise. So 9 BY multiply by 96 mm, then minus equals to 22 mm. Oh sorry, it is actually 24. So over here is 24. So 24 is equals to 0. So we need to find the By. So after finding the By, we can find the F resultant force, which is already known. We can find the gripping force. So this is the second free body diagram, already proven. So the force acting By and Bc, so it's moving component, so By downwards, Bx, Cy, Cx. So let's do the summation. Let's do the summation Fy. So Fy negative 300 Newton, and Cy it's going upwards, so it is plus Cy. Then By it's downwards, negative By is equals to 0. So let's do the summation moment. It's equals to 0. So we take a reference point of C as a reference point. So for here we start from here, negative 300. You know why negative? Because it's going clockwise. And 448 mm. Y, so plus By, and then 12 mm is equals to 0. So let's take out our calculator and do the calculation. So By is equals to 11,200 kilo Newton next to By is equals to 11096 mm minus F 24 mm is equals to 0 200. So this one times we getting 1075200 negative 24. So the force is equals to 44800 Newton. We convert to kilonewton, it will be 44.8 kilonewton. So the gripping force here is 44.8 kilonewton. Let's start doing question number 3. So first let's take a look at the question. The bucket of the front end loader carries a 300 Newton load. The motion of the bucket is controlled by two identical mechanisms, only one of which is shown. Knowing that the mechanism shown supports 1/2 of the 300 Newton, determine the force extracted. The first question, by the cylinder CD and a member of AB, by cylinder of CD and a member of AB. Then by the cylinder of FH by pin G. So let's do it. So over here, the first free body diagram of ours is Because ours is the bucket. So I've driven the bucket and the force reaction FA and the diameter and the weight 300 Newton and AD. So divide by 2, 3000 Newton divide by 2, because they already stated over there that it's controlled by two identical mechanisms. So 1500 Newton. So summation of moment D as a reference. So negative AB is because it's going clockwise. So plus 1500 Newton, it's pushing downwards, and the diameter is 0.4 and also here 0.4. So FAB is 1500 Newton, the force reacting over there. So we already found the FAB. So secondly, we need to draw the second free body diagram of B. So take a look at this one. B, C and E, this one over here. So I already drawn the free body diagram of the BCE. So tan theta 0.2 or 0.1. So theta we got here is 63.43 angle, and the summation of moment is summation, we do this clockwise. So don't forget to put this one. So the summation of moment, reference point as E. So we take at this one over here E. So 1500 and the diameter 0.6, this one, and the FCD is over here, and cos 36.43 angle, and the diameter of 0.4 plus by FCD sine 63.43 over here is equals to 0. So as we calculate by using the calculator, we will get 10,058.4 Newton. Then summation of x is equal to 0. So negative EX is basically this side plus by the FCD we got over here. The force is 10,058.4 and the cos 63.43 minus by 1500 Newton. So EX we will get 2999 Newton. Then summation of Y is 10,058.4 sin 63.43 minus by EY over here is equal to 0. So EY, as we press this to in calculator, we will get 9899.6. So the answer over here is 8996.12 Newton. So for the EY, we got the answer of 8996 Newton.12. So this over here, EY is a compression. So next we gonna find out for the member AB cylinder by cylinder FH by pin G. So we will be focusing on D, E, F, G. D, E, F, G. So I have drawn the free body diagram and put the reaction force. So the length is over here 0.2, 0.3, 0.14, 0.75. So all of this length is converted to meter. So at the below here is 0.4, 0.5, 0.75, and the force reaction E, and the D over here, and the G, X, G, Y, and F theta here. So let's go to the equation. So at first what I did is I got the angle of the theta, or two theta over here, theta 1 and theta 2. So theta 1 is 21.80. The second theta is 45 degree. So basically it's a formula. So I did the summation. So yes, let's do it. So FFH sine 45, 0.5, 0.15 over here, then minus by FFH. So the FFH is basically over here. So FFH negative 55H cos 45, 0.6 is the length, minus 2999, 0.15 plus 0.3, 0.15 plus 0.3, and 8996.12 multiplied by 0.5 plus 0.6, 0.5 plus 0.6, then plus 10,058.4 Newton multiplied by sine 2 1.80 multiplied by 0.4 plus 0.5 plus 0.6. So over here, this one minus by 10,058.4 cos 21.80, and the length 0.2, 0.3, 0.15 is equals to 0. So over here we need to find the half h. So half h, by calculate using the calculator, I got 36,809.04 Newton for the T point. So the summation of fx is equals to 0. This is basically what the summation x lah. So whatever it's going to the x direction, I put it up here. Negative 10,058.4 cos 21.8 plus 2999 minus 36,809.04 sine 45 plus gx. Gx is basically the unknown over here. So I just calculate by using the calculator. So 32,368 Newton, and the summation of fx is equal to 0. So I got negative 10,058.4 sine 21.8 plus 8,996.12 plus 36,804.04 cos 45 minus gy is equal to 0. So gy going there is become negative, so I got 31,288.64 Newton. So question 3 done. So the pin reaction Fx and Fy we already found out. So that's all from me. Thank you.
So here is the question 4 from the assignment given. So the question is, arm ABC is connected by pins to a collar at point B, and to crank CD at C. Neglecting the effect of friction, determine A, the couple M, forces at B, pin B, C, pin C, and D, support pin D. Required to hold the system in equilibrium when data equal to 0 and 90 angle. So here we must draw the free body diagram from point C till A here, and then we draw it from C till D. So step 1, we draw the free body diagram and we must apply the equation of equilibrium of moment at the point C. So we go and we do the equation and we get the P. So and then we continue doing the force in Y component, and we get the Cy as we did in the equilibrium. So then we proceed with Fx and we get Cx, which is 240 Newton, and we continue from the C point till the D point as shown. So we must draw the free body diagram as here shown, and we go and do the F in X which is equal to 0, and Cx already we got it, so we do it and we get the answer. And here the same with dy, we get it from the previous one. So we go and we do the equation of equilibrium of moment here. You can say that it is anti-clockwise value as here. So we go here when data is equal to 90 angle. So we draw the free body diagram. I do the same steps. We do apply the equation of equilibrium of moment, C point, and we add here the 90 and we continue with the equation and we'll get the P, and then we go to the force in Y equal to 0. So we go and get here the equation. We get Cy, which is equal to 135 Fx, which is Cx, which is equal to 0. So we continue. We do the free body diagram from point C till D, and we get apply the equation of equilibrium of moment. We do it as shown here, and Cx, which is equal to Dx, equal to 0, because both equal to 0, as here we get Cx. So dy, we go to the force in the y component. We see dy, which is equal to 135 as we get it here. So lastly, the moment, it's as the equation, we get the 40.50 Newton. And
Salam sejahtera Encik. My name is THIVINESH SOMESHWAR, son of P.JAYA KUMAR. My metric number is P0922100450. So right now I'm going to explain about question number 5. So the question number 5 is to hydraulic cylinder control of the position of the robotic arm A, B and C. Knowing that in the position shown the cylinders are parallel, determine the force exerted A by each cylinder B by pin B, C at support F. Okay, when P is 250 Newton and Q force is 150 Newton. So this is the free body diagram for A, B and C over this part. Okay, so summation of moment B is equal to 0. So negative 250, because it's anti-clockwise, so that's why we're taking negative. So negative 250 bracket 600 millimeter times 10 power of negative 3, so the bracket plus FAE 405. This 405 we're taking the theorem tables over here, and then bracket 150 millimeter times 10 power of negative 3 is equal to 0. So we're just gonna write down the same thing over here. So negative 250 bracket 600 times 10 power negative 3 is equal to FAE 405 150 times 10 power of negative 3, the bracket. So the FAE is 1250 Newton. Okay, so right now the summation of Fy is equal to 0. So negative 250 plus By minus 1250 bracket 405 is equal to 0. So the By is 1250 Newton. So the summation of Fx is equal to 0. So it's negative 150 plus Bx is equals to 1250 By bracket 3 over 5, same theorem Pythagoras, 3 over 5 equals to 0. So Bx is equals to 900 Newton. So right now we're going to see about the free body diagram for B, D and E. Okay, B, D and E. So this is the drawing. Okay, so as you can see, Fx, Bf, Dg is parallel to each other. So the theta is 90 degrees minus 36.87 over here. So the theta is 53.13. This place is 53.13. So tangent 53.13 is equals to 400 times 10 power negative 3 over x. So the x is 300 times 10 power negative 3. So we're going to find the y. So for the y is cos 36.87 y over 200, this one 200 times 10 power negative 3. So the y is 160 times 10 power negative 3. Actually this is the 10 power negative 3 is 160,000, so it's like 160,000. So that's why I just simplify it and just put it like this. So the summation for moment F, okay, we can take this F over here, is equal to 0. So FDG is 160 160 times 10 power negative 3 minus 1250, the earlier for by, bracket 300 times 10 power negative 3 bracket plus with 900 bx, 400 times 10 power negative 3 is equals to 0. So the FDG is 93.75 meter. Okay, so and then we're gonna find the summation for Fy is equal to 0. So Fy is equals to 750 plus with FDG cos 36.87. So it's like 750 plus 93. This FDG is 93.75 bracket cos 36.87. So the Fy is 844.55 meters. So we're gonna find for the summation of Fx is equal to 0. So the Fx is 600 plus FDG sine 36.87. So it's 600 plus 93.75, this one. Okay, sine 36.87. So the Fx is 652.25 meters. So that's all from me. Thank you very much.